what is blockchain?
Prepare for launch. 3, 2, 1.
Blockchain is to Bitcoin what internet is to email. Like you need internet in order to be able to send an email, and you need the blockchain in order for you to transfer a Bitcoin from one person to the other person. Some fun facts over here. Blockchain is coined later on. It's not even mentioned once in Satoshi Nakamoto white paper. And here on the right hand side, I have this picture of 3 railway with trains on it. You can also think of blockchain like the railways, and the trains is the cryptocurrency on it. So basically, there are many different types of railway, and just like there are many different types of blockchain around, and there are many types of train, and each railway would be able to let different trains on it, because sometimes some railway actually allows different types of train to run on it. And if you have heard of Trans-Siberian Railway, when you cross from Mongolia to China or the other way around, the railway change a little bit. So basically what they need to do is they need to change the wheel, the bogie of the train, because the size of the track is different. So this, you can think of this as like, if you probably have heard it a lot, that people are talking about interoperability of blockchains, and that is very important because it is when the interoperability is possible that it gives more functions or usability to the blockchain. So think of it as like what we are trying to do it over here from blockchain, different blockchain to different blockchain. So this is what they are calling, if you heard of some of the word, they calling the bridge, where it bridge from one blockchain to the other blockchain. So you can think of blockchain and the cryptocurrency and the applications as in the relations of the railway and the train. Just give you an example, Bitcoin is one. Bitcoin is a bit interesting, is the cryptocurrency is called Bitcoin. The blockchain, the platform itself, is also called the Bitcoin. But if you want to distinguish it, you call it Bitcoin blockchain. And Ethereum is another blockchain, and the cryptocurrency is called ETH. And for example, the blockchain NAM with the cryptocurrency called ZEN. So there are many different blockchains around. Some have a bit of difference of technology than the other one, but generally they bear this similar concept. First, they are distributed, they are transparent, yet it's anonymous, it's immutable, secure, and whether it's fast or economic, it depends. And we were going to talk about this one by one. If you want to visualize blockchain, it kind of look like this. They look like train, right? Like, one car is linked to the other car. But the link over here is not the chain, it's cryptography. So why is it called cryptocurrency? A lot of it is also because cryptography is used in this blockchain technology. Talking about the first characteristic, let's go back to many years back, 10, 20 years back. Client server is the network that we are all familiar about. I mean, especially if you are working in the tech field, definitely you know about it. And even though you are not in the tech field, client server, I'm sure you guys have heard of it. That means that there's one server and all the other computers access the data or write the data to this server. During that period of time, storage is quite expensive. So a company probably have only one major server. Then when the storage become more cheap, they might have like a few more servers at different locations, so to keep it safe. in case it has any breach or physical damage to one server, there are still others to back it up. But now, data storage is getting more efficient and cheap, and it makes distributed network more possible with the availability of internet as well. And what's the difference of the decentralized network with the distributed network is, for decentralized network, there are still server. Most of the information are still kept in the server. The clients are basically just querying the data from the server. But in distributed network, every single one of those computer, or we usually call it nodes, that connected to each other in this network would have the same copy of data. It means that like they do not need to query the data from the server. They have the data within their own device, so they can query the data right from their own device. How they're gonna what the difference here is, when there is any data that added to the network, they will need to share it with everybody in the network. So everybody was going to have exactly same copy of the data. It sounds like a lot of redundancy, but yes, it is redundant, but it is the redundancy in the network that actually make the blockchain secure. Why? We're going to discuss more later. Now, talking about the immutability of the blockchain, we keep on talking that any data that like you have been written to the blockchain, you won't be able to change it. Usually, when we write something to the database, we can either write to it, we can edit it, we can delete it, or we can just query and build it. But for blockchain, you can only write to it and build it. You can't edit it, and you can't delete any information that have been put on the blockchain. Why? Look at this. Here is like a 4 ledgers over here. Now, blockchain is also called a distributed ledger technology because just like Joanna mentioned just now, is ledgers that links together. So what is ledger? Let me bring you to the accounting system. In accounting system, we have a lot of ledgers, right? But each of the ledgers would have like recorded every month. You have monthly ledger that we are talking about over here. So in a ledger, you always have an opening balance. Then you have the transactions that happen during that month. Then you're going to have a closing balance. And this closing balance is going to be brought forward to the next month ledger as the opening balance. And then that month is going to have the transactions happen during that month. And then you will have a closing month balance for that month. And that closing balance is going to be the opening balance of the next month. Okay, I'm not going to keep on going like this because it doesn't make sense. But then you get the idea, right? So exactly the same, what's going to happen in the blockchain ledger is all the information from the previous ledger and what happened in this ledger, including one of the random number, is going to be added together, and using a cryptography algorithm, then you will generate something called a hash, which the hash is going to be used as the link to the next ledger. And the next ledger accumulate all the transactions happening during that period of time, and then it will, together with the algorithm, generate another hash, which is going to use to link to the next ledger, just like how the opening balance and the closing balance of the accounting ledger. Now, in accounting practice, if you find that you have done something wrong, like recorded a wrong amount to a transactions that happened like 6 months ago, what you should do is have another transactions in this month ledger to contrast the amount, so to make it right. You should not go back to the ledger 6 months ago change that amount to the correct one. Because if you do that, the closing balance for that month is going to change. And that's going to affect the opening balance of the next month ledger. And that is going to affect the closing balance of that month ledger. And then it's going to affect the opening balance of the next ledger. Now you can see the ripple effect over here. It's exactly the same concept for the ledger in the blockchain, but what's the difference is cryptography is used here. Now for the accounting ledger, it's easy, it's just number. You just need to calculate it. But for here, the hash is almost impossible to be reverse engineered. I give you an example what I mean by here. 2 plus 2 equals to 4. So if I give you 2 plus 2, it's very easy. You know that the answer is 4. But if I give you 4 and I ask you, you need to give me the equations that add up to 4. It's not necessary 2 plus 2. It can be 1 plus 3. And it can be also 1.5 plus 2.5. And it can also be 3.5 plus 0.4. The possibility is countless, and that is why it's impossible for you to change anything in the any transactions in the ledger of the blockchain because of this factor. Another characteristic that people always say is that blockchain is very secure. But why? The cryptographically connected ledger make it very difficult to alter anything on the blockchain. And then the distributed network as well. Now, think of all this ledger, whatever happens on this ledger are distributed to every single node in the network. We are not talking about 2 computers in the network, 3 computers in the network, or even 10. Now we are talking about hundreds and thousands of computers connected to this network. If you are going to change any transactions, say that I have sent 10 Bitcoins to V, and now I kind of regret it. I hope that I didn't send that much to V. Says I would like to go back and change the transactions. And even if I change the copy I have with my device, that doesn't mean that I can change it. I have already changed the transactions because remember, everybody in the network has the same copy of the data. They are going to look at their copy and say that no, Ivy, you have actually sent 10 Bitcoin to V, not 1. You are giving us wrong information over here and we do not agree with your information. So that also one of the way to keep the network, the informations of the blockchain secure. Another way to keep it secure is because it's transparency. Everybody in the network, or even anybody not using the network, can be able to check what have happened in this blockchain, who have sent the transaction, who have received a certain amount of transactions. Nobody can hide from a public blockchain. So that is one of the reasons why it is safe. Another one is the consensus protocol. The consensus protocol is just like what I said just now. Even though I have changed my copy, I won't be able to say that I have my record is correct, because the rest of the people, the majority, say their information is correct. So this is a few main factors that keep the blockchain secure. And over here, I did on the left-hand side, the icon, 2 keys over here, say is the private key and the public key. Because any information, any transactions that you want to do over the blockchain needs an account or address. And basically, they are a key pair. The key pair is the private key and the public key. The public key is just like your bank account, for example. With the bank account, other people will be able to transfer money over to you. And the private key is like your ATM pin. with the ATM PIN, you will be able to withdraw money from the ATM machine or transfer money to somebody else using the ATM machine with your PIN number. And if you have lost your PIN number, you wouldn't be able to move your funds. Of course, you can go to the counter, but let's say, ATM is your only way, you won't be able to access your fund. And if anybody get to know about your PIN number, they can move your money. So being able to keep your private key private is another way to make sure your assets on your account is kept. And private key have one more very important functions over here to keep the whole your transactions secure is you sign all the transactions with your private key. And with that, it also gives another layer of security here, because someone else using a different private key would have a different outcome, and that won't be recognized. So the security of the blockchain is not done with just one thing, but many factors come together. And last but not least, let's talk about if blockchain is fast and whether it's cheap. Cost and speed is relative terms. It depends on what you are comparing it to. Now, Bitcoin does have a 10 minutes block. It means like averagely almost every 10 minutes a block is created, and your transactions can only be considered included or successful when the block is created. Like when you swipe your credit card and then you have to wait for it to confirm. But says if you want to just buy a bar of ice cream over the counter and you have to wait for 10 minutes for your transactions to go through, I think whoever is lining behind you is gonna curse. But comparing that, if you are transferring money internationally, which now generally takes about a week, 10 minutes is like cooking a fine dining comparing to instant noodles. And then if you're talking about like buying the ice cream over the counter using cash, I don't have to pay any extra transactions fee. But with blockchain, every transactions you made need to pay a fee. And if you are comparing it with your international remittance cost, whatever you pay on the blockchain transactions, it could be much less. It depends on the fee and depends on the currency price as well. So it really relative. And talking about whether it's burning a lot of energy because of the mining, I kind of like debate that, because printing money or maintaining our internet banking do cost a lot, including the cost of printing, maintaining the stuff, distributing it, even destroying it. All these are costs that it's very difficult for us to calculate it. But mining the Bitcoin or other cryptocurrency is easy to calculate however much power has been used. So people have been like talking about this, which I myself think that like is really debatable, because we haven't included any other costs into maintaining the whole fiat system that we have. Yeah. After we're talking about all those, like why exactly we want to use blockchain? The one fundamental thing that blockchain solves is the trust issue, and trust is a scarce commodity. Think about it. Why we need the bank while transferring money from one person to the other person? Most of the time is because the both parties do not trust each other, and they give the rights or put this trust onto a third party, a so-called trusted third party. And are these third parties out there are always trustable? I think it sometimes can be quite a debatable questions as well. And then that is why the blockchains over here and we put the trust on the algorithm, and the algorithm is always have a deterministic outcome. Now, I'm not saying here that the institutions is not to be trusted. They have been there and serving us for a long time. But I'm talking about that is alternative here. And if we go back to look at it, Bitcoin started basically is during that period of time when these institutions failed us with all the system they have. They not be able to sustain because of some of the regulations or the products that they have rolled out.